So, welcome to the lecture on comparing means between two groups. We're going to look this week at a test called the t-test, and it was originally developed by a guy named Student, so you'll sometimes hear it referred to as Student's t-test. So let's go ahead and take a look at just a review. I want to look at a little review from last week because we were talking about chi-square, and some of the people in class had a little issue on how to report chi-square results. And this is how. Basically, say there is a significant relationship between marital status and education. Chi-square equals 0.06. The degree of freedom, again, is equal to 1, and P is greater than, is less than 0.05. So pop over again to part 1. We want to say, in a particular instance, that there is a significant relationship between marital status and ethnicity. So report the chi-square results. Chi-square equals 6.7, and that's your Pearson's chi-square number. Your degree of freedom equals 1. P is less than 0.05. However, this is a weak relationship because we got a phi of 0.13. And if you recall from the numbers that I gave you last week, that is a weak relationship. Part 2, we present the percents. Okay, and so we would say that 63.5% in this instance, n equals 113 people who have never been married are minorities, and 63.5% and 113 of white people are married or have been married in the past. And part 3, what we want to do is identify main trends in the table and explain. So, we would say, why are white people more likely to be married than certain minorities? So these are just samples on how to report chi-square from a sample question in the book. This is sample SPSS output, and some people said, gee, what percentages do we use? And this is actually from a piece of research that I was doing just recently, and it's for a lineup, a photo lineup, and with 8 photos in it, and whether people made correct or incorrect decisions in identifying a perpetrator when multi-perpetrators were present at the crime. So in the one perpetrator condition, when there was only one perpetrator doing a holdup, for instance, people made correct decisions at the rate, 72 people made correct decisions at 92.3, and that's the observed frequency, and people made incorrect decisions at 7.7% right here. When we introduced another perpetrator, what happened was that correct decisions went down to 81.6%, and incorrect decisions increased to 18.4%. So we were able to tell from looking at the chi-square, or just the crosstabs really, that incorrect numbers did increase. And of course, what the Pearson's chi-square would do, what it do? You tell me. That's right. It would tell us if that finding was significant or not, and in this case, it was. So these are the most commonly used methods for testing bivariate associations. Don't forget, bivariate just means two variables. Chi-square is the one that we use for two nominal or ordinal variables, and then we use mean tests. We're testing the mean or the average, and those are the t-test and the f-test. One is for interval or ratio, and one nominal. So, and the other is correlation, two interval or ratio variables. Okay, we won't be talking about that, this correlation or the f-test this week. So the logic underlying mean test is that we want to assess whether differences in means between groups are statistically significant. So here's an example. The average starting salary for males significantly different from that of females? You get it? It's really that easy. And another example is there a significant difference in the average salary of UNH students versus students from other institutions after graduation? See, this is really a useful statistical test. It's a t-test. So my research question would be posed like this. Is this difference in means between males and females, UNH students versus other students, due to chance, that is, non-significant results, or can we presume that we would find this difference again if we were to replicate the study? In other words, are the means between the groups we are interested in comparing different enough not to be attributed to chance or random occurrence? Okay, and I just want to remind you that about statistical significance, or P. Okay, significance levels indicate the likelihood that a result is due to chance, or not due to chance. A common level of significance used is 0.05, and that's the alpha, you remember? This means that the finding has a 95% chance of being true. True means that the finding is replicated in the population, remember? So in other words, there's less than a 5% chance that the findings are attributed to chance or just randomness. And if you were to replicate the study with another sample, it is likely that you'd obtain the same results. So establishing significant differences is dependent on these three things: how substantial the differences in means or averages are between the groups, the sample sizes in each group, and the variance of each category of the dependent or DV, dependent variable or DV. The variance equals the spread around the mean. You remember that? We looked at that, I think it was in week 2. Less spread around each respective group's mean means that there's more difference. More spread around the mean in each group means that there's less difference between the groups. So the measurement level requirements for mean tests are that the dependent variable, the DV, must be an interval or ratio variable, and independent variables, IVs, can be nominal or ordinal. And hypothesis testing, remember with chi-square, is that the null hypothesis is that there is no association between the two variables, whereas the alternative hypothesis stated that there is an association between the two variables. Okay, let's generate a hypothesis with mean tests. Okay, the null hypothesis is that there is no difference in the means between the two groups in the population. Okay, mean 1 equals mean 2. The alternative hypothesis is that there is a difference in the means between the two groups in the population. Okay, here's an example of a null hypothesis. The average level of fear of crime is the same for men and women. Or the exposure to media violence has no effect on children's average aggressive behavior scores. Or 3, there is no difference in the average IQ of students enrolled in criminal justice major than those enrolled in a forensic psych major. Here are the different types of t-test. There are 3. The first is called a one sample t-test. The second is called a paired sample t-test. And the third is called an independent sample t-test. And this is the one that we mostly use. The one sample t-test means that in a one sample t-test, the sample mean is used to test a hypothesis about an unknown or hypothesized population using the t-distribution. Okay, the objective of that is to test whether the means of a single variable differs from a specified constant. Here's the example. To compare UNH professor's salary to the average professor's salary in Connecticut, and that's the constant, okay? And this is the single variable. Okay, and paired sample t-test means that there are two sets of data from the same sample with repeated measures on the same individuals. So let's say I test someone before I give them a drug. I give them the drug and then test that same group of people again. So it's repeated measures. All right, to compare, here's an example. To compare the means of two variables for one group. Example, stats students' proficiency in statistics measured before and after the course. Obviously, you're going to be better in statistics after you watch all these wacky videos. Paired samples t-test or related samples t-test means that when the data is from the same sample, let's say it's a depression score before therapy and after therapy, anxiety scores for the same students before the exam and after an exam, we refer to this design as a repeated measures or within subjects research design. Okay, don't forget that. These two things are important. These two terms are important. Repeated measures or within subjects, because we're within the same subjects. An extension of this concept is the matched subjects study. The sample is not the same, but it's purposely matched by the researcher on some criteria. And what I mean by that is here's an example. Selecting a male with IQ of 120 from one sample and matching him with another male with the same IQ from another sample. Okay, we'll work with repeated measures as this one is the most commonly used method. The same procedures apply for a matched subject design also. Okay, but we're going to just be working with that matched. With the repeated measures. And here's what Graviter and Wallnow say about repeated measures. They say a repeated measures study is one in which a single sample of individuals is measured more than once on the same dependent variable. The same subjects are used in all of the treatment conditions. In a matched subjects study, each individual in one sample is matched with a subject in the other sample. The matching is done so that the two individuals are equivalent or nearly equivalent. They've got to be as close as possible with respect to a specific variable. For instance, we talked about the IQ or more that the researcher would like to control. Okay, and this is the logic behind a paired sample t-test. And I'm going to skip over to the next video here, so I'll see you there.